am Dr. Sherry-Ann Brown with FITSontheGO, and with me I have Professor Ray. Professor Ray, welcome to FITSontheGO.
Thank you very much for the invitation.
We're so glad to have you here with us, and we'd like to ask you a couple of questions. Tell us more about the technology of RNA interference, and tell us about how you've been able to use that to block PCSK9 synthesis.
We know from the monoclonal data that PCSK9 inhibition, when you block it in plasma with a monoclonal, knocks or reduces LDL cholesterol by 50 to 60%. So using this small interfering RNA, and in this case a compound called inclisiran, what we can do is that essentially get this oligonucleotide into the hepatocyte. What then has to happen is it's a double strand. There is an enzyme called dicer that separates the two strands. The antisense strand then is incorporated into a naturally occurring complex called RISC, and this stands for RNA-induced silencing complex. So this carries the machinery that is going to cause messenger RNA cleavage. So now you've got your binding strand, binds to the target of interest, and now that can be spliced, it can be broken down. And the beauty of this is actually it's such an efficient process. A very small amount of oligonucleotide lasts a long time in the system, so you've got a very long half-life. And then in slowly dividing cells, when the two cells divide, that whole complex of the silencing RNA silencing complex gets passed on to the next cell. It's diluted, but it's there. So the potential for this is to last for a long time, meaning you need fewer injections or a smaller volume. So a lot of work has been done in other disease areas, and the medicines company and Alnylam have developed this. And in the phase 1 study published in the New England Journal a day or so ago, 69 patients, a single dose, and then a second dose at about a month, suggested you could achieve about a 50% reduction, possibly up to 6 months. Numbers are small, so you get the usual challenge of small numbers. What's real? So this is an appropriately powered study to basically get 90% power to be able to spot a 30% difference between any of the active treatments and placebo with a single injection on top of statins. We basically need at least 400 patients, and we actually recruited 501. So what we've got are half this number that will have a single injection, and we've got LDL measurements at different time points, and the other half will get a second injection at 90 days. And the primary endpoint is actually percentage change in LDL of the active treatments compared to placebo at day 180. Secondary endpoints are other lipid parameter changes, looking at the time course. And what we're reporting here is a pre-specified interim analysis of the 90-day endpoint. So we pre-specified this because the trial is ongoing and we've got to get the 180-day follow-up. So we will look at that in due course and maybe present that next year. So the other secondary endpoint of interest are the safety endpoints. Is this safe? What happens to LFTs, etc. And the principal findings are that we've established the dose that we'd like to take to a phase 3 study, because the idea of a phase 2 design is you want to exclude a low dose because it's too low, and you want to basically find a dose that actually if you went up further you get no added benefit, right? So we've done that, and what you'll see is that essentially that there are doses, essentially all of the doses provide sustained reduction with a single injection all the way through to 90 days. And with the top 2 doses, you're actually getting a 50% reduction maintained at day 90. At that point, in some of these patients, we're providing a second injection to answer 2 questions. 1, do you get further reduction in LDL? And if you like, with that second boost, do you go out further? So what we will have eventually when we get the follow-up longer data is we might be in a situation where we can see that maybe 2 to 3 injections a year gives you sustained reductions in LDL. We've looked at AEs, SAEs injection site reactions, rashes, etc., are extremely low. The numbers are of the order of 1 to 2%, much lower than monoclonals, which average out at about 7 or 8%, much, much lower than the antisense technologies tested to date. CK abnormalities, LFTs, no difference, no Hy's laws. So we haven't seen any safety signal in the 90-day data, but obviously the thing about this is that, people might say, well, it's just one injection. You might not expect people to, get a reaction, but it's working over that time. So, it's not our fault that it works so efficiently, right? So if you put all that together, what's the potential for this? What's our biggest challenge in the real world? Patients not taking tablets. Even with the monoclonals, for example, it's self-administered, right? We know from some data that people are getting a script. They are getting a script, but they're not collecting the script. So you could have a situation where you go to your doctor and the nurse in clinic gives you a shot twice a year, and you maintain your LDL at 50%. And if we show that that is safe, and in the future, maybe in an outcome study, it reduces CVD, wouldn't that be an incredible thing when we know what compliance is like in the real world, and achieving these differences in LDL is a problem? So that's really the take-home.
Professor Ray, that sounds like a fantastic study that has tremendous potential for transforming patient care.
We'd like to think so. We hope people enjoy the presentation. There is more to come because only half the number have been followed up to 180 days. We will have 210, 270-day follow-up, which will then show next year. Can you imagine that? 2 injections?
That sounds fantastic. We can hardly imagine how helpful the outcomes will be, and we're really excited to be able to incorporate that into practice.
Well, thank you very much for the invitation to come and speak to you today.
Thank you so much for being with us. This has been FITSontheGO with Professor Ray. For more videos, visit us at youtube.com/FITSontheGO.